Hi everyone, in this presentation we're going to be covering the contractile cells, which are the cells that will be stimulated by the nodal cells to contract. So contractile cells will be the ones that will be contracting to expel the blood from the heart. When we were talking about the nodal cells, we did see that the cell membrane had these sodium potassium ATPase pumps, which are also present in these contractile cells. So we can see right over here that the sodium ATPase pump will be pumping 3 sodium ions outside of the cell and 2 potassium ions inside of the cell. Now these sodium ions, they do want to come into the cell, and the potassium ions do want to come out of the cell. But these cell membranes, they are made up of lipids, right? They're made of fat. And the fats, they don't really like charged substances. So the sodium sort of bounces off and stays out, and the potassium also bounces off of the membrane and stays inside of the cell. And this means that for sodium to get in and potassium to get out, there needs to be doorways or channels. And the good news is that the cells do have these channels. We will have a channel that's specific for sodium and a channel that's specific for potassium. Now remember that these cells are muscle cells, right? They are cardiac muscle cells. And what do muscle cells want to do? Well, muscle cells want to contract. So when it is not contracting, not doing its work, we say that it is at rest. And when they are at rest, we find that these sodium channels are going to be closed. With the potassium channels, most are going to be closed as well. But some do stay just a little bit open. And this means that some potassium will be able to come out. And when this happens, it makes the inside of the cell less positive, as the potassium ions are positive and they're coming out of the cell. And this will lead to a resting membrane potential of minus 90 millivolts, as we can see over here from this image. Then this cell will get a stimulus, an electrical stimulus. And where is the stimulus coming from? It is going to be coming from the nodal cells that are going to be located in the SA or the AV nodes. And when this stimulus arrives, it opens up a few of the sodium channels, and this will make the inside of the cell less negative. And as we see over here from this image, this will cause it to reach about minus 70 millivolts. And this will be the threshold for creation of the action potential. Therefore, once it reaches this threshold of minus 70 millivolts, it will send a signal to other sodium-gated channels, and there will be a high influx or high entry of sodium ions inside of the cell. And this takes the voltage inside of the cell all the way up to a positive 20 millivolts. And this is what we call depolarization. And this is important because depolarization in muscle cells, they happen like this. And because all these cells are connected by the gap junctions, the sodium will move on to the next cell. So it will go from this cell to the next cell, spreading through a wave of depolarization throughout the muscle tissue. And in this case, the muscle tissue that we're talking about is the heart. After the depolarization, the sodium channels, they will close to be able to reset. And this means that potassium channels then start to open up once it reaches the positive 20 millivolts. Now, the first potassium channels that open are what we call a fast potassium channel. And once they open, because it's a fast potassium channel, then the membrane potential will drop drastically by about 10 millivolts. And right after this fast drop, the fast potassium channels close, and then it opens the slow potassium channels allowing this positive ion to slowly exit the cell. And then the calcium channels also open and they move into the cell. And why does calcium come in? Well, calcium comes in because this is a muscle cell. And you should know that for muscle cells to contract, they need calcium. Therefore, once calcium enters, the muscle cells, they start to contract. But because we have the positive potassium coming out of the cell and the positive calcium going into the cell, it forms this plateau where they will balance each other out. But calcium channels actually close very quickly, and the potassium channels remain open. So the potassium will continue to come out, making the inside of the cell less positive. And it will do this until it reaches, again, the minus 90 millivolts. And this phase is what we call the repolarization phase. Therefore, it's important to highlight that during the plateau period, since we are going to have the presence of calcium, this will be the phase where the muscle is going to be contracting. Therefore, in order for your heart to contract, it needs to first depolarize, because depolarization will actually precede or come before contraction. And then this will activate the sodium potassium ATPase pump, where sodium will be coming into the cell. If sodium is coming into the cell, it increases the voltage of the membrane. It goes all the way up to plus 20 millivolts. Then we have again a little bit of potassium coming out of the cell. This makes the membrane a little bit less positive. We also have the entry of calcium, and this exit of potassium and entry of calcium forms the plateau, which is where muscle contraction occurs. Then the calcium channels close, but the voltage-gated potassium channels, they remain open, and that will cause repolarization of the cell. And then the whole cycle starts over and over again.